Hello, my name is Atharv and this is the second part of Basics of Matlab. So matrices and arrays are very important, if not the most important features of Matlab. They represent seemingly complicated things into groups of numerical data. There are many functions that work with such variables, oftentimes to extrapolate new data. We started to introduce such variables in the previous video, but there is still a lot more information to cover. Here, we will be talking about adding, subtracting, multiplying, taking the dot products of matrices, and higher dimensional matrices. Adding and subtracting and taking dot products of matrices are very similar. All functions consist of using an operator on two corresponding positions of matrices. Here's adding two matrices. So I can set x to 1, 2, 3, and I can set y to x. So both these variables are in the workspace, and if we add them up, like x plus y, for example, each corresponding position of each matrix adds up. For example, the first row of the first first column of x with the first row and first column of y, and that and 1 plus 1, and that equals 2. The first column and the first row of x plus y is 2. And so on. This first row and the second column of x and the first row and second column of y adds up, and that becomes 4. The first row and the second column of x plus y is 4. So the same thing happens when you subtract matrices. So if I do x minus y, since these matrices are similar, it becomes a zero matrix. And if we create a dot product of matrices, we multiply each component by each other. So for example, 1 times 1 equals 1, 2 times 2 equals 4, and so on. So when you take a dot product of matrices, you have to put a dot before the multiplication symbol. Matrix multiplication is a bit different, and I won't go into that much theory, but multiplying matrices is not the same thing as taking the dot product. If you're interested in knowing more, I will put a site that explains it in detail in the description. All you do is multiply both matrices without the dot, like so. X times y. Matrices can have dimensions higher than 2. There are many examples of situations that require this feature. I'll go back to my image processing example in my previous video. In colored images, each pixel has a red, green, and blue value. To represent each RGB value, we have to stack three two-dimensional matrices, each matrix having either an R, G, or B value, creating a three-dimensional matrix. Combining all three matrices creates a colored image. Creating multidimensional matrices are a bit more complicated and require more theory to go along with it. There are many more functions in MATLAB, and if you'd like to know more, you can refer to the MATLAB documentation. Thank you for watching.